Hello, my name is G.Lalith Vignesh. My roll number is 234G1A0577. My branch is Computer Science Engineering and I am from Section B. Today I am giving an Caa-2 assignment PowerPoint presentation for the subject Advanced Data Structure and Algorithm Analysis, whose code is 23CSC301. Today my topic is comprehensive insights into dynamic programming techniques and application for optimization problems. Optimization techniques exploring the greedy method in job sequencing, knapsack problem, minimum cost spanning trees, and shortest path algorithm. Introduction to optimization techniques are crucial in solving complex problems efficiently. This presentation explores the greedy method focusing on its job sequencing, knapsack problem, minimum cost spanning trees, and shortest path algorithms. Understanding these concepts enhances decision making in various fields. What this means is these optimization techniques are very important for solving complex problems, and this involves greedy method, which has mostly applied for job sequencing, knapsack, minimum cost spanning trees, and shortest path algorithms. These algorithms are extremely important for data efficiency and data speed. Without these, the life as we know now might not be possible. A lot of large companies use this to process their large data sets. A lot of investment banking companies, a lot of banking companies, a lot of customer seller companies like Amazon, Flipkart also use this. In job sequencing problem, the objective is to schedule jobs to maximize profit while adhering to deadlines. The greedy method selects jobs based on their profit to deadline ratios, ensuring optimal scheduling. The technique is widely applicable in resource management and operations research. What this essentially means is job sequencing problem is very efficient, very nice, very great for maximizing profit while keeping in mind about the deadlines. The greedy method selects jobs based on profit to deadline ratio, so you can make more profit in less amount of time as efficiently as possible. This is mostly used in resource management and operations research. Even in our college, maybe our HR uses this, or in a lot of big companies, the human resources department is mostly uses resource management for this greed for most amount of profit in less amount of time. The value involving knapsack weights and values to max. In graph theory, a minimum cost spanning tree (MST) connects all vertices with the least total edge weight. The greedy method, exemplified by Kruskal's and Prim's algorithm, efficiently finds the MST by selecting edges based on weight, ensuring optimal connectivity in networks. What this essentially means is MST, which means minimum spanning tree, connects all vertices and least total edge weight. The greedy method is exemplified by Kruskal's and Prim's algorithms. So the greedy method became much more efficient due to these algorithms and finds MST by selecting edges based on weight, ensuring optimal connectivity means the best amount of connectivity that you can get, the best, and in network. Finding the shortest path in graph is like in various applications. The greedy method is employed in algorithms like distros, distros which iteratively selects the closest workspace. This approach is essential for routing and navigation systems, enhancing efficiency and accuracy. This is extremely important for Google Maps and many other navigation systems for GPS. Without this, these apps as we know it may not be possible. Without this, Google Maps would be an utter mess. Without this, GPS would be an utter mess. Without this, a lot of navigation systems would fail, and we would have to rely on physical maps to get from a place to another place. So this greedy method, employed in algorithms like discussers, which iteratively selects the closest vertex, is very extremely important for routing and navigation system like Google Maps and GPS. Greedy method proves to be a powerful tool in optimization techniques, offering efficient solutions across various problems such as job sequencing, knapsack, minimum cost spanning trees. and shortest path algorithms. Understanding its principles allows for improved decision making and problem solving in diverse fields. What this essentially means is that greedy method is a really powerful tool that is used in a lot of areas. It is great for optimizing the already existing techniques, but also it can be further optimized by other algorithms. It is extremely used on job sequencing, knapsack, minimum cost spanning trees, and shortest path algorithms, which are very useful in multiple industries and multiple companies. Without this, a lot of economy would be destroyed because a lot of products that we have now would not be possible. The biggest example would be Google Maps. Google Maps would not be possible if there is no greedy method, which is exemplified by shortest path algorithms. Comprehensive insight into dynamic programming techniques and applications for optimization problems. Dynamic programming (DP) is a powerful algorithm technique used for solving complex problems by breaking down into simpler subproblems. It is particularly effective for optimization problems where the solution can be constructed from solutions to smaller instances. The presentation will explore key techniques and applications of DP. What this essentially means is dynamic programming is a really powerful algorithm technique which is very useful in today's time. And how it works is it takes a big problem, it divides the big problem into multiple small problems and solves each small problem by one, which makes it easier for the computer to operate and which makes it efficient and faster. And due to this, we can use it to solve much harder or much bigger problems. Key core principles of dynamic programming. The core principles of dynamic programming including overlapping subproblems and optimal substructure. Overlapping subproblems refer to solving the same problem multiple times, while optimal substructure means the optimal solution of a problem can be constructed from the optimal solution of its multiple problems. What this essentially means is the core principle of dynamic programming is like overlapping the problems that we divided into small parts from a big problem, and overlapping them will create a single one optimal substructure which can be made into a single answer, which will provide an answer to the single biggest problem. So it is an extremely important and great way to solve a problem. Dynamic programming can be implemented using two main approaches, top-down and bottom-up. The top-down approach uses memorization to store results of subproblems, while bottom-up approach builds solutions iteratively from smallest subproblems. Both the methods aim to optimize performance. What this means is top-down approach uses memorization to store results of subproblems, while the bottom-up approach solves iteratively the smallest subproblem, then goes upward and solves all them and mixes them together and creates a one answer for the big problem. Common dynamic programming problems. Several classic problems can be effectively solved using dynamic programming techniques. Examples include Fibonacci sequence, knapsack problem, and longest common subsequence. Each of these problems showcases the power of DP in optimizing solutions through systematic approaches. What this essentially means is problems like Fibonacci sequence, knapsack problem, and longest common subsequence use dynamic programming extensively to solving their problems. Applications of dynamic programming. Dynamic programming is widely used in various fields such as computer science, operations research, and economics applications, include resource allocation, inventory management, and algorithm optimization, showcasing its versatility and effectiveness in solving real-world problems. What this essentially means is dynamic program is an extremely important method of solving problems that is widely used in computer science, operation research, and economics. Without this, a lot of our economy will fall because our lot of economy depends on dynamic programming. Our lot of economy depends on how fast a software can run these days. The speed of the software will affect economy in a way that we can't even foresee right now. And due to that, it has a very great impact on economics and also solve a lot of real world problems. It is used in hospitals, schools, colleges, and multiple places. Maybe not directly, but indirectly they are used. Challenges in dynamic programming. While dynamic programming is a powerful tool, it also presents a lot of challenges like it is very complex to use and it has a lot of memory constraints. Understanding these challenges is very crucial for efficiently applying Dynamic programming to ensure optimal safe performance and resource utilization. Conclusion and future directions. In conclusion, dynamic programming is an essential technique for solving optimization problems efficiently. As technology progresses, the exploration of new applications and enhancements in DP techniques will continue to evolve, offering promising avenues for research and development. Thank you for giving me this opportunity. My name is G.Lalith Vignesh. My room number is 234G1A0577. I am from Computer Science Engineering branch. I am from section B. Thank you for this opportunity.